Okay, this is Drew Cavell doing the reassessment for forces and circular motion, which I did so well on the assessment. So what we have here is an Ewok who is hanging from a cord and he's swinging around a pole. This is an uncharacteristically large Ewok. He's 120 kilograms, pretty big. But of course he probably thinks it's solid muscle. He's swinging around a pole, and the cord is 3 meters long. The cord has a max tension capacity of 2,500 newtons. So if it goes over 2,500 newtons, it will break. So what we need to find is the speed of the Ewok and the angle of the cord right before the breaking point. So what we're going to do here is first we're going to set up our forces diagram, our free body diagram. So we have a force of gravity pulling down on it, and then we also have the force of tension pulling back towards it at an angle of 2,500 newtons. So we're going to come down here, we're going to do our first we're going to figure out the force of the Ewok on the downward force of the Ewok on the string or the cord, which is going to be its mass times the gravity. We're going to come up with 1,176 newtons. Of course, it's negative because it's in the downward direction, downward y direction, which we're then going to use to keep going on in the process. Next, we're going to take that and we're going to do the Pythagorean theorem to figure out what the forces in the x direction would be, which would come out to 2,206.13 newtons in the x direction, positive x direction. And then by logic, we can just assume that 1176 newtons is also what the force in the positive y direction would be. So then we keep going, and now we can, since we have all the sides of the triangle, we can use that to find our theta. And we do that by sine theta of 1176 newtons over 2,500 newtons, which gives us 28.06 degrees. Sorry. Then we use that to come over here and figure out the distance away that the Ewok is, which we can later use to figure out the velocity. So we do cosine of 28.06 degrees equals r, which is the radius of the Ewok from the pole, over 3 meters, which is the cord length. We come up with r would equal 2.65 meters, which we can then use to find our velocity. And we use the force centripetal equals ma. And sorry, it's getting kind of foggy. Trying to make it not so. Alright, there we go. Alright, so we're going to use F equals MA, FC for centripetal equals MV squared over R. V squared over R, of course, is the acceleration in a circle. So we're going to get 2,206.13 newtons equals 120 kilograms times V squared over 2.65 meters. So our velocity is going to come out to roughly 48.72 meters per second, which is the fastest it can go at 28.06 degrees before the cord will break from the mass, from the force of the Ewok. Thank you. Hopefully it wasn't too foggy and grainy for you. Thank you.